I thought that we'd start with just a little bit of limbering up. Those of you that exercise will know that you start by just flexing yourself a little bit before you get into some of the main work. So what I'm going to do now is I'm going to go through some equations and inequalities. This is just a small set of notes. They're at the very end of your PDF file that you've downloaded. And you can look at these. So you don't have to take any notes down yourself today. All of these are online and all of these are in the PDF notes there for you. But there's the section at the end. It's the section it's the last section. And it's called Equations and Inequalities. What I want to do here is just this initial limbering up. And what we're doing is we're actually going through stuff that you already know. So don't be insulted if you start off this and he says, I don't believe he's telling us stuff. We know that for years. What I want to do is I want to just show you what you know already and then maybe look at it slightly differently and say, I never thought of using it like that before. Oh, that's much easier. So bear with me. This will take a few minutes of a journey, maybe 10 minutes or so, 10, 15 minutes, as we go through a whistle-stop tour of all the maths you know and you've used forever. Okay, so it's called Equations and Inequalities. Well, in mathematics, you've got mathematical operators, and you'll see these on your calculator. They come in pairs. So there's a plus and a minus. There's a multiply and a divide. There's a square root and a square, a cubic root and a cube. So there's always a way back. There's the xth root, like the 5th root or the 10th root, and the xth power, the 5th power or the 10th power. Now you did all of these addition and subtraction in junior infants, and you did some of these just in the early stages, maybe 5th class, 6th class, or maybe certainly 1st year, 2nd year. These ones here, the trigonometric functions, sine, cosine, and tan, you started picking these up for your junior certificate. And then these inverse cosines and tans, these are more familiar now to you. You've got log and 10 to the x. A natural log is another number on your calculator, and the opposite of it is e to the x. So there's always a way back. So whatever you do, there's a way back. So what I'm going to do now is I'm just going to ask a very simple addition question. Now, if I were to ask you, if I were to say that x plus 2 was 5, and I asked you what x was, most of you would say, well, x is 3, that's simple. And you know that. But I want to take it a bit slower and say, let's imagine that all you ever want is or all the examiner ever wants really, is the examiner wants x on one side and a number on the other side. It says, what's x? So x is on the left-hand side and the number is on the right-hand side. So what is that number? Now you know that's 3. But what I'm saying is there another way of doing that? Is there a simpler way of doing that? Well, what we could say is x plus 2 is 5. Well, x plus 2 is 5. Well, you say, I don't like plus 2 on this side. I'd much prefer if it was just x. So what's the opposite of plus 2? Well, you say minus 2. And the opposite, if you do it on one side, you must do it on the other side. So 2 minus 2 would cancel, and then you get x equals to 5 minus 2, or x equals 3. Now, that's slower than you would have done it, but it shows what you're doing. You're just getting rid of something you don't like. So similarly, if somebody said y minus 3 is 8, what's y? Well, again, you'd probably say, oh, it's 11. But another way of doing it is to say, well, y minus 3 is 8. Y minus 3 is 8. I don't like minus. I'd prefer if that wasn't there. So the opposite of minus would be plus. So y equals 8 plus 3, or 11. So effectively what we're doing is we're finding out how to get rid of something we don't like. Y equals, we just want y equals 11. So let's see if that continues to be useful for us. Let's say we look at 3x is 12. Well, what's the opposite of 3x is 12? Well, I just want x here. But on this occasion, 3 is a multiplier. So what's the opposite of a multiplier? Well, if it's 3x is 12, I would like to divide both sides by 3. So 3x divided by 3, and the 3's cancel. So x equals 4. And similarly, if somebody said divide y over 5 is 10, how do I get rid of a 5 on the bottom? Don't like 5 on the bottom. I'm going to multiply by the 5. So 5 times that is 5 times the other. The 5's cancel, and I end up with y equals 50. So way back when you were in primary school, in 4th or 5th or whatever class it was, you were able to get rid of the pluses and the minuses and the divides and all of that. We now move up a bit, and we're talking about moving to a few more complicated sums, and we're looking at, say, x squareds. We'd say, what's the opposite of a square? How do I get rid of that square? Well, the linked operator here says the opposite is the square root. So if I were to take the square root of this, it would be the square root of that. So instead of x squared, I get the square root of it. And the only reason I get rid of this, put in the square root, is because the square root cancels the square, and I'm just left with the x in the middle. So the square root of x squared is the square root of 9. They'll all cancel. I'll just be left with the x, and the square root of 9 is plus or minus 3. Minus 3 by minus 3 is plus 9, and 3 by 3 is 9. Similarly, if somebody said, what's the square root of 5 is, square root of x is 5, I really don't like the square root on that side. How do I get rid of a square root? Well, let's just square it. All I know is that if I square a square root, it goes away. So all of that stuff is gone, and I'm just left with the x. So 5 squared is 25. So that's how it works. So you were doing that in maybe late primary and certainly early stages of secondary. You were doing things like x cubed is 8. What's x? I don't know. But I know how to get rid of a cube because x cubed, the opposite is the cubic root. So the cubic root of this is the cubic root of that. And they'll all go, and I'll just be left with x. Now, the cubic root of 8 is tricky enough, but that's a number, and that's a number. There's no x there. So that's just on a calculator. So I go to the calculator, and I look up the cubic. I type in x, or 8, and probably something like a cubic sign, and then I get the number 2. So with my calculator, make sure on your calculator you can get that the cubic root of 8 is 2. So just practice on your calculator so you have that. And lastly, in this space, if somebody said the cubic root of x is 3, I have no idea what x is. But if I cubed this, I'd get rid of it. So I'm going to cube this. Whatever I do on the left, I have to do on the right. So the cubic root of this is this. That looks awful, messy. But the only reason you did it was to get rid of it. And you're left just with the x and the 27. 3 by 3 by 3 is 27. So they're really powerful methods. So anytime you see anything on the left-hand side that's not just x on its own or y on its own, there's a way of unlocking it. So here we've got powers. X to the power of 10 is this. How would I get rid of x to the power of 10? Well, it would be the 10th root. So the 10th root of this is the 10th root of this. So every time all I'm doing is, what's the unlock key? How do I get it? I plug it in, I do the unlock key, they all disappear, and I'm just left with x. And again, that's a calculator. There's no x or y there, just a calculator. So x is 2. And if somebody said the 5th root of x was 2, I mean, that looks complicated. That's a nice leaving cert question. It looks ugly, but you know that the 5th root of x, all you've got to do is to make it to the power of 5 and the power of 5, because that will get rid of it. So, gone. 2 to the power of 5, 2 by 2 by 2 by 2 by 2 is 32. So that's how you did it. So why did I go back all the way to primary with all of that and early secondary? Because the same approach happens later, and it's really, really helpful. So let's look at the thing that is more recent, sine. You did a trigonometric functions called sine, or cosine and tan, sin, cos and tan, dó siúd atá déanamh cuasa scaoilte. So sine theta, how do you get rid of a sine theta? Well, if you look at the calculator, you'll probably find an inverse button or a shift button or a second function button called sine inverse, right? So basically what we have here are the sine and the sine inverse are sort of two sides of the same thing. They actually unlock each other. So sine of sine inverse, theta, is actually 0. Cos of cos inverse is 0. Tan of tan inverse is 0. And similarly, sine inverse of sine is 0. Cos inverse of cos is 0. So really what you have all the time in these sines, coses, and tans are in ways of actually unlocking something. And that's a really, really helpful way of doing things. So we'll see that in a minute. So if somebody said to you, sine of x is 0.5, find x. Well, the way you do this is, I really don't like sine here. So if I were to put in sine inverse here, then I'd have to put sine inverse there. Now, that looks messy, but remember, it's only put in to get rid of it. So that's by x. X is now sine inverse 0.5. That still looks messy, but there's no x's or y's there, just a calculator. So we put in 0.5, hit the inverse, and we get 30 degrees. And similarly, if somebody said to you, tan of x is 1, what's x? Or again, you would just say inverse tan, x is equal to inverse tan, or 45 degrees. And it works the other way around too. So let's say you get an exam question and it says inverse tan of x is 45. What's x? You say, I never liked the inverse tans. They're really awkward. I could get tan, I can't, never liked the inverse. Well, what gets rid of an inverse tan? You just type in tan. Tan of this side is tan of this side. That looks messy, but remember, it cancels it. X is equal to tan 45, and tan 45 is 1. So they're the sort of things that we will use along the way to get rid of stuff that's in our way today as we move on to other topics. Just to finish where we left off, so just remember what we did. You come in this morning and we're looking at something like inverse tan x is 45. How would you have done that before this morning? Well, you might have said, okay, I can do that, but I have to think about it hard. Or you can say, no, I know how to get rid of an inverse tan. You just put in tan in front of it. Tan of tan inverse is tan of 45. They cancel. X is tan 45. On the calculator, X is 1. So that skill now is just something that doesn't faze you. Sine X is 0.5. How do you find out what X is? How do you get rid of a sine? Inverse sine. Inverse sine, sine is inverse sine 0.5. Inverse sine, they cancel. X is 0.5. X is then 30 degrees because that's just a calculator calculation there. Similarly, if you are looking at something like logs, it just takes a little while for that to focus. Log X is 2. How would you get rid of a log? I don't know. But the inverse on the calculator says is 10 to the power of. So 10 to the power of log is 10 to the power of 2. 10 to the power of log x, 10 to the power of x is 10 squared. So x is 10 squared, x is 100. So again, we can solve that question. And in terms of the exponent, if somebody says 10 to the power of x is 1,000, how do you get rid of a 10 to the power of x? Well, you take the log of it. So log is the opposite, and you solve it that way. And finally, you probably saw in your calculator something called ln, natural log x. How would you get rid of a natural log? Again, it's the same as anything else. There's a button called e. E to the natural is e to this. E cancels it. That's a calculator, and it's done. And if somebody said e to the power of x is 12, how do you get rid of e? You take the natural log of it. Natural log of e to the x is natural log of this. So in everything that we do in mathematics, there's always a way back. There's sines and inverse sines, logs and 10 to the powers. And actually in calculus, there's even differential calculus and integral calculus. One gets you back from the other. So there's always a way back, just as there was millions of years ago when you did pluses and minuses. So, thank you.